Welcome to the fourth video of our TensorBoard exploration. Here we're finally going to implement the exciting TensorBoard features to our previous code. So let's get started. We'll look at what specific changes are required in our code and what variables we'll need to store. There's not much to change as we talked about earlier, but the results we get are great. The code on the left side shows us our previous code in which we have not included the TensorBoard functionality, and the code on the right side shows what we need to change in each position to get the desired effect. Here, we're going to add scopes and variables between different fully connected layers. Each scope will contain the variables and nodes it required for the corresponding layer, and each layer nodes will also have their own names for their nodes. The first fully connected layer here is fc_layer_1. It contains two nodes, which are mapmul and bias_add. As we haven't named the two nodes, they'll be named by themselves as mapmul and bias_add, with their names suffixed by its appearing index, making the name unique. Such as the first one will be named mapmul and the second one will be named mapmul1, and so on and so forth. Similar case is with the second fully connected layer. These two layers are connected by a ReLU unit, which are responsible for activating and deactivating the incoming neuron outputs. Adding multiple ReLU layers don't have much effect, but sometimes they increase your accuracy for the validation and test set. For the rest of the graph, i.e. the weights and biases, we're also going to add their names so that we know under what names they'll be shown in the graph. Also, we're going to add histogram and scalar summaries for scalar variables and tensors respectively. Here, the variable names are named such as train_dataset and test_dataset. Also, we've named all the weights and biases variables under the same name, i.e. weights and biases, with their names prefixed by the key of the layer in which they are to be contained. If you want, you could keep the names the same, since they're going to be inside different layer scopes. Their names won't conflict with each other. After adding the scopes, names, and summaries, we have to merge all the data into a single variable merged, and we'll process this variable in a session run step, and after getting the summary result from it, we'll pass this to the summary writer, and it'll store the serialized summaries into the pointed log location. Here the location is /tmp/simple_nn_log. After doing all these changes, you can run your own TensorBoard instance by executing the command TensorBoard --logdir equals /tmp/simple_nn_log. Now play around with the summaries and graphs and see what you can understand from it. You should see the lost scalar summary and the weights and biases distribution during the whole training session. Also, you'll see two fully connected layers in the Graph Explorer, and they'll be connected by some ReLU units. Here's a bit of an exercise. Try adding an accuracy node in the graph and link it with TensorBoard to store a scalar summary of it and see how it changes during your whole training session. Also, try to see how the updates of the variables are executed in the Graph Explorer and which nodes are connected to it. We talked about what changes are necessary in order to have TensorBoard visualization in our not MNIST code. In short, you need to specify the log location, tell TensorFlow what you need to record, such as events and histograms. Then make a structured view of the graph using scopes and node names. Label every data you want to view, or leave it if it's not important. Merge all the summaries and then create a summary write object, and then process the merged summary when you want to record it and pass the summary result with the current step you're on to the writer to save it to the specified log directory. In this section, we talked about the different components of the TensorFlow visualization toolbox, i.e. TensorBoard, and we talked about events, histograms, and Graph Explorer. These three are the most important parts of TensorBoard, and you should get yourself familiarized with them. Thus, this tool is great, and it's very handy if mastered. It adds a significant increase to your productivity if used often. In the next section, we'll learn about convolutional neural networks, and we'll work on the famous dataset, CIFAR-10. Convolutional neural networks are the most popular area in deep learning and are the basic building blocks of most of the complex networks that we use in daily life. The next two chapters that deals with this are going to be the most important lessons you could learn in the field of deep learning.